So now that we've talked a little bit about the reactive programming paradigm and I described the principles involved, let's start to talk more specifically about the Reactive Streams API that's provided by Java. And we'll explain kind of the patterns that it implements, and then we'll also kind of talk about the key abstractions that it provides, like publisher, subscriber, subscription, and so on. So Java 8 was a major step forward in the evolution of Java because it introduced the concept of functional programming and sequential streams and completable futures. All very cool things. I still, to this day, my kind of fallback, if I want quick and dirty, well, quick and clean parallelism, I go with parallel streams. It just drop dead easy, usually works pretty well. A great contribution in general. But there are other people who didn't want that model, and we'll talk more about why they didn't want the model, and some of the reasons why they didn't want the model are some historical, they have to do with the limitations of threading and so on. And so with Java 9, they introduced infrastructure support into the programming language via something called the Reactive Streams mechanism and the Flow API. So there's a class called Flow, which has a bunch of interfaces defined in it. And with these infrastructural enhancements or additions, it then became possible to support stream-oriented publish-subscribe patterns, publisher-subscriber patterns, or pub-sub patterns. And they basically work kind of like this. They combine two patterns from the good old Gang of Four book. The first pattern is the iterator pattern, where subscribers can inform a publisher or publishers, I can accept this many items at a time. So that's kind of a pull model. You say, you could send me up to 8 items at a time. Thank you very much. So that's kind of like the iterator. It's really something called batch iterator, but it's basically the idea where you could say, give me some items. And then there's another pattern, another Gang of Four pattern called the observer pattern, which, unlike the iterator, which applies a pull model where you're saying, I would like you to give me these things, the observer says, please send me items, publisher, when you have something to send me. So in that case, it's a push model where the publisher, which acts as a so-called source, will push one or more items to one or more subscribers, which act as sinks, so source and sink, a concept you see in all kinds of different engineering fields. So those are the two patterns, and you can see here that the subscriber says, I'd like to have you send me events, and then the publisher says, here's a bunch of events up to the number that you want. And then the subscriber can say, thank you very much. Please send me the next tranche of events. Publisher will push those events. So it's kind of this push-pull model. Now, the Java Flow API defined 4 interfaces that were intended to ensure interoperability of reactive streams implementations. And this provides the basic building blocks for all the other stuff we talked about, like Project Reactor and Akka and RxJava and so on. And here are the 4 interfaces. They are Publisher, which allows a subscriber to subscribe, and then the publisher can push events to it. Subscriber, which has a bunch of methods that the publisher calls back when it's got something to say. A processor, which is both a publisher and a subscriber, so you can actually chain these things together, and you can have a source, which is a pure publisher. You can have a sync, which is a pure subscriber, and then in the middle you can have these transformer things, which are processors, which are both publishers and subscribers, depending on which way you're looking up and down the stream. And then there's this other interface called a subscription, which can be used to mediate how many requests a publisher should send to a subscriber before waiting to be told to send the next chunk. So that's the Flow API. Those are the 4 classes. Here are the main abstractions in the Flow API. So there are 3 main abstractions here, and the processor is the merging together of publisher and subscriber. So first we have the publisher, which, as you might expect, are sources that can produce 0 or more events that can be pushed to subscribers. We have subscribers, which are sinks that can register and consume events that are pushed by publishers. So far, so good. We have a means of publishers being able to send events to subscribers. So one type of event, as we'll see, is called the on-next event, and you could have 0 or more of these things. And that can be followed by either an on-error or an on-complete optionally. And we'll explain that in a second, too. And publishers send events or push events to subscribers by invoking one of these three hook methods. There's a subscription abstraction that's used to control the flow of events between a subscriber and a publisher. And basically, it can be used to exert what's known as flow control or rate control. And basically what happens is the subscriber says, please send me up to 3 events. The publisher sends 3 events. Then the subscriber says, send me the next chunk of events. The publisher sends the next chunk of events, and so on and so forth. A flow involves interactions between these 3 key abstractions. So the way it works is the subscriber starts by subscribing to a publisher, which says, I'd like you to please send me data. However, very much like Java streams, everything is lazy. So nothing actually happens. No processing occurs whatsoever until a subscribe call is invoked. And we'll talk more about that. It's a little mysterious at first, but it makes sense once you see examples. When the publisher receives the subscribe call, it calls back on the subscriber and invokes its onSubscribe hook method. And that gives the subscriber a chance to say either, send events to me as fast as you can and I'll deal with them, like a superhero, or it says, send me 3 of them at a time or 5 of them at a time. Send me in little batches because I can't deal with more of that. And we'll talk more about why that might be necessary in a bit. So the subscriber can say, send me n of the events, or it can send me all the events as fast as you want. And then once that little handshake's taken place, the publisher can start to send notifications. And they do that by calling the onNext hook method, which will then start the flow of events traversing through the stream of processors, because there's often processor streams. There's often stream processors inserted between the source publisher and the sync subscriber. Note that there can be 0 or more onNext events, and that's what forms a stream. So something may never generate anything, it may never generate anything at all. That's perfectly plausible. Something could generate an infinite number of onNext events. That's also perfectly plausible as well, although you have to be careful with that, obviously. Now, assuming all goes well and the publisher finishes whatever it's doing, it can then send an onComplete method indicating to the subscriber and everybody along the way, we're done. So onComplete it's kind of, think of onComplete like end of file, if you're familiar with reading files in Unix or Windows and so on. It's kind of like, we're done. And then if something goes wrong, instead of generating a onComplete call, it can generate an onError hook method, indicating what went wrong with a throwable, which is basically an exception. So you can either do one of 3 things. You can either never generate, with 4 things. You can never generate anything. You can generate things infinitely, in which case onComplete and onError are never called. You can have the publisher succeed, in which case it could, and finish, in which case it'll call onComplete, or something goes wrong along the way and onError is called. So those are basically the 4 things that can happen with a stream. So that's the end of the overview of the API. Now, the first thing to notice here is that there is not much to it. And yet, when you start looking at some of the APIs we're going to cover, like the flux or the parallel flux, especially the flux, there's like 300 methods in that interface. And you're like, holy moly, there's like only a handful of things here. What happened? And you'll see that to be useful in practice, we have to add a heck of a lot more stuff than just those very simple APIs we talked about in the Flow API for the reactive streams.